Let's take a look at this problem. So number 6. Got the integral from 0 pi over 2 of cosine to the 6th power. There you go. Now, this is using Wallace's formula, but if we were to use the other technique, where you have sine and cosine to an even non-negative power, use your power reducing formulas over and over. So it would be a nasty, nasty problem. Because this is 6, so we'd have to have cosine squared times cosine squared times cosine squared, and we'd have 1 plus cosine 2x over 2 times itself 3 times. When we did that, we'd end up with just something that wouldn't be pleasant. I'm not even sure if it'd work out, to be honest. At some point, we'd have to use some other kind of substitution. Now, here's Wallace's formula. We've got 2 choices. N is odd and N is even. And you see this applies to cosine right here. Well, in this problem, we got 6. So N is even. So we'll use our second form here. Okay. 0 to pi over 2, that's perfect. That matches 0 to pi over 2. And cosine and the n is our power, that'd be 6. So that tells us we're going to have 1 over 2 times 3 over 4 times 5 over 6 until we get to n minus 1 over n. Let's focus first on this, and then, of course, we've got our pi over 2. But n minus 1 over n. Okay, it's always best to start with that one. So if you plug 6 in for n, I'm going to have 6 minus 1, which is 5. And if I plug 6 in for the n there, I got 5, 6. Now going backwards, notice the pattern. So that's 5, 4, 3, 2, 1. So 5, 4, 3, 2, 1. It appears like I left a lot of extra space here. And then, in addition, you need the pi over 2 at the end. I don't think anything cancels. Okay, so that's 15 pi over 2 times 4 is 8, 48, 96. 24, 48, 96. Okay, that'd be your answer. Now, pretty easy. Now, note down here, it says these formulas are also valid when our cosine is replaced by n. You asked to prove both formulas in X tries 87. But that'd be that problem. Now, recall, we have these from Calc 1, some derivatives, and then our Pythagorean, tangent squared x plus 1 equals secant squared. Let's take a look at number 7. Let me erase that. Got the integral of secant squared. (9x plus 4) dx. Now this one doesn't have any note underneath here. I should have put a note saying it's nothing out of this section. secant squared, the integral of it is tangent. If I go back to my basic integration rules, so don't try to apply these techniques if you already got a formula for it. Now it is a u substitution, so we let u equal to 9x plus 4. du, the derivative of that is 9, and I put on dx. So I put a 1/9 out in front, and I need my 9 inside. Excuse me. So then the 9x plus 4 gets replaced by u, the 9 dx gets replaced by du, and this becomes secant squared u du, which we know is tangent. So it's tangent u plus c. And then we plug our u in, which is 9x plus 4, and plus c. And that's our answer. I'm getting over being a little cold. I hate to tell anybody that when this day and age with the pandemic, but it's not the big virus. Grab a drink here. And I'll put the note underneath to help us figure out what to do in this problem. They got a little bit longer version of that in the book. Okay, so I got secant to the 4th, 5x minus 2, dx. Now this is the case where you have secant to an even non-negative power. You could keep two secants and change the other powers of secant to tangent using Pythagorean identity. You keep two secants. We got 4 secants, so I'm going to put 2 here. And here's my 2 I'm going to keep. So those are the ones I'm saving. I'm not going to mess with those. Now these other ones, I want to change to, the tangent. But before I do that, well, I guess I can go ahead and do it. Then we'll do our u substitution. Now, this is why I gave you these right up here. Secant squared is equal to tangent squared plus 1. So this becomes tangent squared of 5x minus 2 plus 1 times secant squared of 5x minus 2. Well, our formula is such that we can't have that 5x minus 2, so it's a u substitution. So I let u equal to 5x minus 2. du, the derivative of that is 5 dx. I have the dx, but I don't have the 5, so I'll put a 1/5 out in front, and I'll put a 5 inside. So then this becomes 5x minus 2 here gets replaced by u. So we're going to have tangent squared u plus 1. We're going to, interestingly enough, do another breakdown of this. We'll see that. This 5 dx is going to be replaced by du, and we have a secant squared. But that secant squared should be u because of that, then du. Okay, now I said we're going to have another breakdown. because we got tangent squared plus 1 in there. So I'm going to multiply the secant squared through. So we're going to have the integral of tangent squared u, secant squared u, du, plus the integral secant squared times 1 is secant squared u and du. Then I'm going to rewrite the tangent squared as tangent u to the second power, secant squared u, du. And over here, the integral of secant squared, nothing special there. That's our tangent. Right here, number 14. Integral of secant squared is tangent. So that's tangent. And I'll go ahead and put the plus c on there. Now here, I need to do another u substitution, but I already got a u there. So I'm going to have to go back to put that back in. But let's say w. W is equal to tangent u. dw, the derivative of tangent, is secant squared du. So we get 1/5 the integral of w squared dw. I replace the tangent with w. That gives me my w squared. I replace secant squared u du with dw. Plus tangent u, and then my plus c at the end. Okay, so we got 1/5 times, add 1 to my power, divide by my new power. And that comes down. Well, first let's plug in the w back in. We said w is equal to tangent. So we're going to have 1/5 times 1/3 tangent u to the third power plus tangent u plus c. Now let's scoot back up and see what in the world u is equal to. U is equal to 5x minus 2. So I'm going to plug in that 5x minus 2 everywhere I see a u. So I got 1/5, 1/3, 5x minus 2. Sure, I put that in the right place. Plus tangent of 5x minus 2 plus c. Multiply the 1/5 through, and I got 1/15 tangent third power of 5x minus 2 plus 1/5 tangent of 5x minus 2 plus c. And that would be your answer. Okay, number 9. Got the integral of tangent to the 5th, 9x dx. And the instructions say, case, this is where you have tangent to an odd, non-negative power. It says keep 2 tangents and change to secants using the Pythagorean identity. It should say, and change the rest of the tangents. And change the rest No, I think that's right. And change to secants using the Pythagorean identity. Let me think this through. Derivative of tangent would be secant squared. So keep two tangents and change those to secants. Okay. Now I see it. Though I probably don't have it worded very well. Now, we're going to keep two tangents. So I'm going to put tangent squared over here. It's probably not keep. It probably should be separate. And then we're going to rewrite this because there's no way you can rewrite an odd power with using the Pythagorean identity. That's why I knew something wasn't quite right in my wording. That's version 1. I tried my best. So tangent squared. Tangent squared is this bottom one here. And notice that there's not a plus 1 here. So tangent squared is equal to, we take the 1 over the right side, would be secant squared minus 1. So this would be secant squared minus 1 dx. Now I'll multiply this through, and I'll separate them into separate integrals. So tangent to the third times secant squared, so we're going to have tangent third 9x secant squared of 9x dx, and then the negative 1 times that gives us negative, and then tangent to the third 9x dx. Now, first off, I'm going to apply two substitutions here. I'll do u is 9x, du will be 9 dx. Okay, so put the 9 out in front, or not 9 out in front. I put the 1/9 out in front, and I put the 9 inside. I put it in front of that. Dx. Now tangent to the third. You know, that we just said. Tangent to an odd non-negative power, you keep two tangents and change the secants using the Pythagorean identity. So minus, and we're going to separate off two tangents. So we're going to have tangent 9x. And here's our two tangents we're separating off, dx. Okay, so back to my first one here. It's like two separate problems at this point. The 9x's gets replaced by u. The 9 dx gets replaced by du. So we're going to have tangent of u to the third power, secant squared of u du. Notice the way I wrote that with parentheses. We'll come back to that. It'll be another substitution. Minus, and I won't flip back there because we have the example right here. Remember how we wrote tangent squared of secant squared minus 1? So we're going to rewrite that as secant squared minus 1 dx. Okay, back to my first one here. I'll let w equal to tangent u dw. Derivative of tangent is secant squared, so that's secant squared u du. So that becomes 1/9 the integral of w to the third dw minus, here's our second integral. I'm going to speak someday. I'll multiply the tangent through, and I'm going to split those into separate integrals. So I guess this minus has to affect everything to the right. So I'm going to have tangent 9x secant squared 9x. Negative 1 times tangent x, so negative the integral of tangent 9x dx. Or actually, I should have dx in each one of those, but that's okay. You get the idea. Well, here, add 1 to my power, divide by my new power. So 1/4 w to the 4th minus, now if I let this be equal to u, then du would give me this. But I want to make sure that I've handled because our formula doesn't say 9x. So I'm going to do a u substitution. Boy, there's so many variables here. I messed that up, I think. But the good part of it is it's the same u is up here. So u is equal to 9x, du will be 9 dx. So I put a 1/9 out in front, and I put a 9 inside. Now tangent, it's an odd power, but over here at property 10, tangent is equal to negative natural log of cosine. But it's a u substitution. So u is equal to 9x again. Du would equal 9 dx. Let me put my dx on there. So I put the 1/9 out in front, and I put a 9 inside. Boy, if this doesn't hurt your brain, then that's 1/36. W, I said, was tangent, so I'll plug that back in. Tangent to the 3rd power of u minus, that becomes 1/9, the integral, and u, the 9x gets replaced by u, and 9 dx gets replaced by du. So this becomes tangent u secant squared u du minus 1/9, and the 9x here gets replaced by u, and the 9 dx gets replaced by du. So this will be tangent u du. We'll put the plus c on at the very end. Now u up above was 9x, so I'll go ahead and put that in here, and that way I'll be done with that first one. Minus, now I do another substitution here. W equals tangent, and dw, the derivative of tangent, is secant squared du. So this becomes the integral of w dw. We replace the tangent with w and the secant squared du with dw. Minus 1/9. Now this is already in a perfect form that matches the number 10 exactly. So that'll be a minus natural log, the absolute value of cosine u. And I'll put my plus c on here. I'm getting close, I think. 136 tangent to the 3rd power of 9x minus 1/9, add 1 to my power, divide by my new power, minus, or negative becomes a positive, so I can bring that out. And natural log, the absolute value of cosine of u, and u is set to 9x, plus c. Okay, so we got 1/32, or 36. I would say it's a long day, but it's only 1:30. That's 1/18. W. What in the world was W? W is tangent. So that gives us tangent squared u plus 1/9 natural log of the absolute value of cosine of 9x plus c. And 1/36 tangent to the 3rd of 9x. This minus will flip the sign of everything, so that's minus 1/18 tangent squared of u, and u was 9x, minus 1/9 natural log of the absolute value of cosine of 9x plus c. And that's our answer. Assuming no math mistake somewhere in there. Don't make no guarantees when I get that many steps. Okay. We'll take a look at this problem. I think I got time. Tangent to the fifth of 8x minus 1, secant to the fourth of 8x minus 1 dx. Okay, you have secant to an even non-negative power. It says you keep two secants, change other powers secant to tangent. Okay. This one looks pretty easy, actually. That means that we're going to keep 2, and we have 4, so I'm going to have 2 here, and I'll have 2 here. These are the ones I'm saving for my my derivative. These are the ones I'm changing. And going back up to here somewhere. Secant squared is equal to tangent squared plus 1. So we're going to rewrite this. Tangent to the fifth, 8x minus 1, and rewrite this as our tangent squared plus 1. Secant squared, 8x minus 1. Now I'm going to multiply that tangent to the fifth through. So that's going to give me tangent to the fifth times tangent squared gives me tangent to the seventh, 8x minus 1. And tangent to the fifth times 1 gives me a plus tangent to the fifth of 8x minus 1. And secant squared here. Now we're going to have to do a double substitution here. I'll first start off with u. U is equal to 8x minus 1. Du would be 8 dx. So I need an 8 inside, 1/8 out in front. So then the 8x minus 1s get replaced by u. The 8 dx gets replaced by du. So this becomes tangent. Let's try it again. There we go. This becomes tangent of, and we're replacing the 8x minus 1 with u, so tangent u to the 7th power plus tangent u to the 5th power. And let's see, bracket, I guess. Yeah, bracket. And that's secant squared u du. Now, I'm going to let w equals to tangent u dw. The derivative of tangent is secant squared u du. So tangent u's get replaced by w. The secant squared gets replaced by dw. So this becomes 1/8 the integral of w to the 7th plus w to the 5th dw. So we got add 1 to my power, divide by my new power. Add 1 to my power, divide by my new power. Plus c. Now we're going to plug in our w. W we said was tangent. So we're going to have 1/8 tangent to the 7th power, u, plus 1/6 tangent to the 6th power of u, plus c. Then we'll plug our u back in. U we said was 8x minus 1. So it gives us 1/64th tangent 7th, no memory. It's 8x minus 1. Multiply the 1/8 through here, and we get 1/48, 1 over 48, tangent to the 6th of 8x minus 1, plus c. And that's our answer. Let's see where I'm at. I might have time for one more problem. Okay, so these are product sum formulas, so nothing exciting there. Now here, this is the case where you have one of the following: cosine of something times cosine of something. They're different. Sine of something times cosine of something, or sine of something times sine of something. Then you use your product sum formulas. Okay, so let me clear that off. Okay, so number 11. Got the integral of cosine of 4x times cosine of negative 2x dx. Now, sometimes you can get rid of the signs so you don't have to worry about those, but oftentimes it doesn't hurt to leave them in here. Cosine of a negative angle becomes cosine of the positive angle. It's because it's an even function. If you got a negative, you can drop a negative. Now, this applies to my second formula here. You can see that m and n represent numbers. So the m here would be 4. The n would be 2. So we're going to rewrite this as 1/2. It's the bottom one because it's cosine, cosine. Cosine, it's 1/2 times cosine, and then I got m minus n. 4 minus 2 would give us 2x. And then plus cosine, and over here is m plus n. 4 plus 2 is 6. That gives us 6x dx. Now 1/2 I can put clear out in front and not worry about. And I want to put these into two separate integrals. So there's going to be the integral of cosine of 2x dx plus the integral of cosine 6x dx. These are both the substitutions. U is equal to 2x, du would be 2 dx. I'm going to say this is u also, but realize there are two separate u's. So that's 6 x, and du would be 6 dx. Which means that first integral I need a 2 in there, so I put a 1/2 out in front. And the second one I need a 6 in there, so I put a 1/6 out in front. So that gives me 1/2, and then I put a 1/2 out here, so I can put a 2 inside. Here I'll put a 1/6 out in front, so I can put a 6 inside. So that becomes 1/2 times 1/2 the integral of cosine u du. Keeping in mind that u is what I'm considering different than the u over here. So this will be cosine u du. Might have been better if I used w's along with u's, but oh well. The integral of cosine is sine. So that's 1/2 times 1/2 sine, and this u is 2x, plus the integral of cosine is sine. So this becomes sine of this u, which is 6x, plus c. Multiply the 1/2 through, and I get 1/4 sine of 2x plus 1/2 times 1/6 is 1/12 sine of 6x plus c. And that'd be my answer. Now I'm going to have to finish this a little bit later. So next time, and where to start. Okay, let's take a look at this, or actually, where am I at? This problem. Okay. That's where I left off, number 12. Okay, I've got the integral of sine negative 3x cosine of 5x dx. Well, if I come back here, this is the second formula. We got sine, cosine. So I'm going to rewrite it with product to sum. Now m is whatever's in front of our x here, and n is whatever's in front of the x there. So our m is going to be negative 3, and the 5 is going to be our n. Now that negative you can actually just put clear out in front. That's the nature when you got a negative inside, is that you can just come out in front, but we'll leave it there. So n is 5. So we can rewrite this using this formula. So I got 1/2 sine of m minus n. So m minus n, that's negative 8x. And there's a plus there. Then sine m plus n. Negative 3 plus 5 is 2, so that gives us 2x. And then dx. Okay, 1/2 I can put clear out in front. And I'll split these up. Now I'm going to go ahead and put this negative on the outside, just so I don't have to worry about it. So that'd be sine of 8x dx plus the integral of sine 2x dx. Now both of these are used the u substitution. So this would be u is equal to 8x, du would be 8 dx. So I need a 1/8 out in front. This one, u would be 2x, du would be 2 dx. So that means I'll put a 1/2 out in front. Okay, so we got 1/2, and then I'll put a negative 1/8 out in front, and this becomes sine u du. Here I'll put the 1/2 out in front. Excuse me. And that's the integral of sine u du. Keep in mind those are different u's. So I'll multiply the negative 1/2 through as I do this. So I got 1/16. The integral of sine is negative cosine u, and though u in this problem was 8x, so I'll go ahead and put it back in. And then negative 1/2 times 1/2 gives us negative 1/4. And the integral of sine is negative cosine u, which in this case u is 2x, plus c. So that gives us negative 1/16 cosine 8x. Negative negative is positive. Just double check and make sure I didn't mess up on signs. No, I'm fine. Cosine 2x plus c. And that'd be your answer. Okay. Now here's some more formulas. Our integral formulas, our derivative formulas, and then our Pythagorean. So let's take a look at this problem, number 13. Grab a drink here. This wasn't even in the book, so I made up my own rules. Cotangent to the 9th x. Hopefully it worked. That's a key. Cosecant squared x dx. Now this one is where you have cosecant to an even non-negative power, which is what we have. It says keep two cosecants. Well, that's all we have is two cosecants. Change other powers of cosecant to cotangent using Pythagorean identity. Since we don't have any other cosecants besides those two we're keeping, then I probably can do it use substitution direct, assuming the derivative of cotangent is cosecant squared. Well, let's see. Let's see if the derivative of cotangent is equal to negative cosecant squared. Close enough. So if I rewrite that as cotangent, is that a 9? Oh, cotangent 9th power. Never mind. Cotangent x, the 9th power, cosecant squared dx. If u is equal to cotangent x, du will be equal to negative cosecant squared x dx. So we need a negative inside. Well, that's easy. Put a negative on the outside. Because negative negative gives you positive. So then this becomes a negative. Replace the cotangent with u. So that's u to the 9th. And replace the negative cosecant squared dx with du. Add 1 to my power, divide by my new power, plus c. And then I'll plug my u back in, the cotangent. So I got negative 1/10 cotangent to the 10th power of x plus c. And that's our answer. That one is pretty easy, actually. Okay, let's take a look at this one. Number 14. Got the integral of cotangent to the 5th, cosecant to the 3rd, dx. And what I say is have cosecant to an odd non-negative power. Keep one cosecant and one cotangent. Change everything else to cosecant. Okay. So this is cotangent to the 4th power. This is cosecant squared. And I said we want to keep one cotangent and one cosecant. We keep those for our derivative. Okay, keep one cosecant, one cotangent. Change everything else to cosecant. So cotangent to the 4th is cotangent squared times cotangent squared. Here's our keeper here. I can touch those. Now, cotangent squared, if I take the 1 over, cotangent squared is equal to cosecant squared minus 1. So this becomes cosecant squared minus 1 times cosecant squared minus 1 times cosecant squared, and then my keeper, cotangent cosecant dx. If I FOIL these, I get cosecant to the fourth power. Cosecant squared times -1 is a negative cosecant squared. -1 times cosecant squared is -2 cosecant squareds. -1 times -1 is a +1 times cosecant squared. And then my keepers, cotangent and cosecant. Now I multiply a cosecant squared through cosecant squared distributive property times cosecant fourth is cosecant sixth. Cosecant squared times -2 cosecant squared is -2 cosecant to the fourth. And cosecant squared times 1 is cosecant squared. Now, the reason why I wrote my steps such that to rewrite all these in terms of cosecant is I'm assuming the derivative of cosecant is cotangent and cosecant. We're screwed if it isn't. Okay. Derivative of cosecant is negative cosecant cotangent. Close enough. We just need a negative in here. Okay, so if we let u equal to cosecant x, I'm specifically talking about the cosecants in here, du from my formula is negative cosecant cotangent. Negative cosecant cotangent dx. We got the cotangent, we got the cosecant, we got the dx. The only thing that's missing is a negative. Put negative there, negative out in front. So then this becomes negative the integral of u to the 6th minus 2u to the 4th plus u squared. That's from all this. And all the rest of it becomes du. Okay, so I've got negative here. Add 1 to my power, divide by my new power. Add 1 to my power, divide by my new power. Add 1 to my power, divide by my new power. Let's see. That negative is going to flip the sign of everything, and I'll plug my u back in, which was cosecant. So I got negative 1/7 cosecant to the 7th power of x. That plus 2/5 cosecant to the 5th power of x minus 1/3 cosecant. Why is that a 6? Add 1 to my power, divide by my new power. Okay. X plus c. And that's our answer. Well, that's a close one, but I made a mistake. Probably have other mistakes in there, but caught that one at least. See that old man. Didn't used to make those mistakes. I probably did. Probably didn't notice. Okay. Now I think this one I put on here so that we could change things in terms of sine and cosine, because that's some of what the problems we're doing in the book. So this is number 15. Integral of cotangent to the 5th over cosecant dx. Cotangent is cosine over sine, so that's cosine to the 5th power x over sine to the 5th power x, all over cosecant is 1 over sine dx. Now I can flip this, multiply times the top. So cosine to the 5th over sine to the 5th times sine over 1. And then that gives me cosine to the 5th x over sine to the 4th x dx. And what am I going to do here? I got cosine to the 5th. That means, I believe, I want to keep one of those cosines. And I'm left with cosine squared times cosine squared over sine to the fourth, and I've kept one of these cosines. Now I'm going to rewrite the cosine squares in terms of sine. So it's just from the Pythagorean. Cosine squared plus sine squared is equal to 1. Solve for cosine squared, and you get 1 minus sine squared. I'll write out, since I wrote it out for about every other problem. And same thing here. Over sine to the fourth, and then cosine x dx. Boil that. 1 times 1 is 1. 1 times negative sine squared is negative sine squared. Negative sine squared times 1 is negative sine squared, so that's negative 2 sine squared. Negative times negative is positive. Sine squared times sine squared is sine to the fourth over sine to the fourth cosine dx. I split those into separate fractions. And I'm going to have 1 over sine to the fourth minus 2 sine squared over sine to the fourth plus sine to the fourth over sine to the fourth cosine x dx. Now I'm going to rewrite all those as sine to a power. This, I can take sine to the fourth power up on top, becomes sine to the negative 4. These, that's 2, this is sine squared. That cancels the 2 of these, so it gives me a sine squared down below, bring it up on top. I've got minus 2 sine to the negative 2. And those cancel, gives me 1 cosine x dx. Now if I let u equal to sine x, du will be cosine x dx, which matches perfectly. I got cosine x dx. So this becomes u to the negative 4 minus 2u to the negative 2 plus 1 du. Add 1 to my power, divide by my new power, minus 2, add 1 to my power, divide by my new power, and 1 goes to u plus c. Now I'm going to plug my u equals sine back in, so that's sine to the negative 3, and so I'll take it down below. I'll put this negative here up on top, so I've got negative 1 over 3 sine to the third power. Negative negative gives me a positive 2. Now I plug sine in for the u here, and I get sine to the first power, so that just gives me just sine x down here, plus u, which is sine x, plus c. And that's our answer. Okay. And one last problem. Get it back. There you go. 16. Integral of sine squared x cosine of the fourth x dx. Now you really never want to rewrite the bottom part. So I wouldn't rewrite this as cosine squared times cosine squared and then rewrite as 1 minus sine squared times 1 minus sine squared. This will have multiple items on the bottom. You really want to have a single item down here. So I'm going to focus on the top. Sine squared I can rewrite as 1 minus cosine squared. I don't know if this will head anywhere, but we'll see. Then split them up into separate fractions. 1 over cosine of the fourth minus. So far, I'm not seeing what I need to do yet. I'm not working off of the script here. I'm live. Just kidding. All What's very random in terms of secant? That helped me any. I think it might actually. Because 1 over cosine of the fourth is secant. Now here, this cosine squared cancels one of these, and that leaves me a cosine squared down here, so that'd be a minus secant squared. And I know the derivative of tangent is secant squared, so if I save a secant squared here, so if I factor it out, this secant squared is one I'm going to save, and that leaves me, oh, is that, it's been a long day. I'm going to cheat. Let me go back up here, not there, must be the other one. Is that equal to tangent squared? Secant squared minus 1, sure enough. Take that over there, that gives you tangent squared. Oh, this is going to work out really nice. So I got secant squared. And this would be tangent squared, and I write it as tangent x squared dx. There's probably an easier way, but like I say, my brain's sluggish at this point. Derivative of tangent is secant squared dx. So I replace the tangent with u, the secant squared dx with du, and I'm going to have the integral of u squared du. Add 1 to my power, divide by my new power. And I don't think I'm doing this right, but it'll give us the correct answer. I'll plug my u back in. And that gives us this right here. The reason why I say I don't think I'm doing it right is because I think the instructions in the book are specifically to use cosines and sines. So I don't know, what do I do that then? This would be cosine of the negative 4 minus cosine 2x dx. I mean, we did use cosines and sines. Maybe that's, I'm not seeing how to work that. They're not non-negative powers. I don't know. I'm pretty sure I did it the right way. This is correct, by the way. I'm just not sure according to their instructions. I'm not sure if I wrote the instructions down here. Maybe they use any technique. Okay, we'll call it good there then. So let me stop the recording.